Alrighty, so we have reached the end of our talk about balancing equations, and this is the final podcast in our series. And this is another example of a word equation. I figured another example would be good for us. And this one is a little more complicated. So we're gonna write this out, and in this type of word equation, you aren't just given the products and the reactants and the nice little arrow that means yields in the middle. You're given a sentence that describes a reaction. So in this particular case, when sodium chloride is combined with lead 2 nitrate, a precipitate of lead 2 chloride is formed along with a solution of sodium nitrate. So I'm going to go ahead and get started with this, and we're going to start with step 2, because I think it's actually really important in this case to work a little backwards, because it's important to know where the reactants and the products are. So sodium chloride and lead nitrate are combined in this reaction. When things are combined, generally they react. So things that react are, of course, called reactants. So I'm going to go ahead and, with your permission, and you're giving me your permission by watching this podcast, I'm going to go ahead and write those out as my reactants. Lead 2 nitrate, that's the left side of our equation. So now on the right side, we must have the other two. A precipitate simply means a solid produced in a chemical reaction. We don't need to note that down just yet, but I'm gonna put it in anyway. So lead 2 chloride is one of our products, and then we have sodium nitrate. And I may not have quite enough room to get this in, but you'll get the idea. Now, the next step is to get the correct formulas. So I'm going to go ahead and check that off because we're working on that. Sodium chloride first. We have Na and we have Cl. Sodium is positive 1, chloride is negative 1, as you can see from looking on your periodic table. So we crisscross them and we get a formula of NaCl. I don't think I need to tell most of you that, because sodium chloride is one of those that's just pretty familiar in general. So now we move on to lead 2 nitrate. So lead 2 means that lead has a charge of positive 2, and nitrate is NO3 with a charge of negative 1. Again, if you didn't know that, you could look it up. So we crisscross, we run these down, and PbNO3 2 is the correct formula. So that's the left side. Now we got to get the right. So I'm going to go ahead and work over here, even though we're not directly underneath. Lead 2 chloride. Lead 2 is there, and chloride is negative 1, so we crisscross those, and we end up with PbCl2. And finally, we have sodium nitrate. The sodium ion is Na+, the nitrate ion is NO3-, so we have NaNO3. So now, we've taken care of the first two steps, which really, for most of you, is the hard part. We struggle, a lot of us, with getting the correct formulas for compounds. So if we get that step out of the way, and if we do it the right way by showing all of our work so we have it right in front of us, we're going to be in really good shape, because now it's just a matter of counting. So I'm going to make a grid as usual. We're going to have some atoms on the left and the right side. We'll have sodium there. We'll have chloride there. I'll put lead. And then again, since they appear on both sides, I'm going to go ahead and treat nitrate together. So we have one sodium on the left and one on the right. We have one chloride on the left and 2 on the right, so we'll have to do something about that. One lead and one lead on the left and right. And then we have 2 nitrates on the left and 1 nitrate on the right. So here's the deal. We need to make sure that we, one by one, we balance these compounds. So, first one, sodium. I'm not going to mess with that unless I have to. Chlorine, you need one more on the left. And so the only compound that has chlorine in it is sodium chloride. So we're going to go ahead and put the number 2 in front of that. So now we have 2 chlorines, but remember, putting a coefficient in front, as we talked about when we counted atoms last week, changes everything in the compound. So we also have 2 sodiums. Now, in order to balance sodium, now we've got to add we've got to have two sodiums on the other side. The compound that contains sodium on the other side happens to be sodium nitrate. So we have to add a coefficient of 2 in front of sodium nitrate to make it balance. Now, of course, adding the coefficient changes the other side as well. So now it turns out that we have 2 nitrate ions. But hey, it looks like we needed 2 nitrate ions to get it balanced anyway. So if I'm not mistaken, and you can feel free to check my work, if I'm not mistaken, I believe we are good to go. So we have made a grid. We have added coefficients until we have the same number of atoms of each element on the left and the right. We have dealt with all the special cases. I think we're done. And so hopefully, now that you're armed with all this information and all these good examples, you can go off, get some of these equations on your own, and even apply it to things we're going to do in the lab. Thanks for listening.